Good morning, students. Today we are going to see the next part of water treatment process, that is filtration. Though screening and sedimentation remove a large portion of suspended matter, but they do not effectively remove fine flock, color, dissolved impurities, and microorganisms. So the removal of all these can be accomplished by filtration. So the outline of today's topic goes like this: definition of filtration, theory of filtration, mechanism of classification of filtration, and filter troubles. So, filtration is a process of passing turbid water through a filter media where impurities larger than the pore size of filter media gets arrested. So, during this process, turbidity, colloidal matter, color, and bacterial content can be considerably removed. So all this can be accomplished by mechanism of filtration. So when water is passed through the bed of filter media, usually consisting of clean sand, the following action takes place. One is mechanical straining, the other one is sedimentation, third one is biological action, and fourth one is electrical action. So all these actions or all these mechanisms help in accomplishing filtration. So that can be seen through the sketch. So this is rough sketch what I have shown here of a filter. So this filters usually consists of fine sand and it consists of gravel in its tank. So this gravel and fine sand acts as filter media over here. So when water is passed through these filter media, water trickles down. So when water is trickling down, all those four actions takes place. How they take place, that we will see. So now first action is mechanical straining. So you can see from one side we have raw water entering into the tank. So this raw water is having turbidity greater than 10 NTU. So when such water is passed, what happens? All the impurities greater than the pore size of this filter media will settle down on top of this fine sand and only water will trickle down. So the impurity is settling on top. You can see the impurity which is settling is marked with green color line. So this process of impurity settling above fine sand or getting arrested above fine sand which is having lesser pore size. Sand is having lesser pore size. So impurity, if it is greater than that of pore size, it gets arrested on the fine sand. So this process is called as mechanical straining. Now coming to the second method, that is sedimentation. Now when we have sand, when we put sand in a container, you can see there will be some space between those sand particles. So the space between those sand particles are known as voids. So these voids which are present in between the sand particles, so now when impure water is moving down, the space between the sand particles, okay, which we call voids. Now if these voids fall one below the other, they are forming a tube. Now these tubes are called as tube settlers. So the impure water, when it is trickling down, so if it is having any colloidal impurity, that colloidal impurity settles down in this void. So this process of colloidal impurity settling in tube settlers is known as sedimentation. So this is second process. One is mechanical straining and the other one is sedimentation. Now third one, biological action. So when a filter is put into commission, that is this filter bed, and raw water is passed through it, during the first few days, the upper layer of sand grains become coated with reddish brown sticky deposit of partly decomposed organic matter together with iron, manganese, aluminium, and silica. So the green clear layer what you're seeing, okay, it will be earlier reddish brown color. Okay, that is the impurity which is settling on top of fine sand. Okay, so it will be rich in organic matter, partly decomposed organic matter, iron, manganese, aluminium, and silica. After some time, they exist in the uppermost layer of sand film of algae, bacteria, and protozoa, etc. So when algae protozoa start existing, their color changes, it becomes green. So that is the green color, what you can see, that green color line. So that green color layer, so that impurity which is settling on sand, we call it as dirty skin, or sometimes it is called as smooth stack. Sometimes it is called as smooth stack, which acts as an extremely fine meshed straining mat, which acts as an extremely fine meshed straining mat. So the organic impurities in water become food to different microorganisms residing in the filter bed. So the bacteria not only break down the organic impurities and convert them into harmless compound, but also destroy each other and maintain a balance of life native to the filter. So this is how biological action takes place. This is third part of filtration. Fourth part is electrolytic action. So this is another function of filter. So this function is to remove the particulate matter by electrostatic action exchange. So the charge of filter media neutralizes the charge of the flock, thereby permitting the flock to be removed. Means the charge of the bed, filter bed, is positive and the charge of the flock is negative. So they exchange the ions and make the flock to settle down. During the process, during this process of exchanging ion, the impurity settles down and we have pure water trickling down. So all these four things are important, that is mechanical straining, biological action, sedimentation and electrolytic action. All if they go hand in hand, we have good filtered water coming out from another side. So this is mechanism of filtration. So which are the filter media we can use instead of sand? One is sand, which is most commonly used. We can make use of anthracite, we can make use of garnet sand or illuminate, or any other locally available material. Locally available material means it may be groundnut coir, or it may be groundnut husk, rice husk, coconut coir. All these naturally available ingredients can also be used as filter media. Then going on to the next part, that is classification of filters. So these classification of filters, there are two major classification. One is slow sand filter and the other one is rapid sand filter. Now why it is called as slow sand filter and another one is called as rapid sand filter is depending on rate of filtration. So slow sand filter was the first filter which was designed. Rate of filtration was less. Rate of filtration was less means the quantity of water which was getting treated by that particular filter was very less. It was in the range of 10, it was in the range of 100 to 200 liter per hour per meter square. Whereas in case of rapid sand filter, the quantity of water treated was more. It was in the range of 3000 to 6000 liter per hour per meter square. Okay, so these two made greater classification of filters. One is slow sand filter, the other one is rapid sand filter. It speaks only about quantity of water getting treated. So this rapid sand filter is again divided into two types. One is gravity type and the other one is pressure type. Gravity type means automatically the water flows down by gravity. Pressure filter means we increase the pressure more than that of atmospheric pressure and make the water to flow down. It is known as pressure filter. So in this sketch you can see slow sand filter. So this slow sand filter, it is having many parts. It consists, a slow sand filter consists of enclosure tank, a filter media, base material, under drainage system and any other appurtenances. Appurtenances means there will be a telescopic head what will be monitoring over there. So when you zoom and see, so it is having a enclosure tank. The entire outer to outer boundary of the tank is known as enclosure tank. So the floor has the floor has a bed slope of 1 in 100 to 1 in 200 towards the central drains. The surface area of tank varies between 50 meters square to 1000 meters square and is found on basis of filtration rate which varies between 100 to 200 liters of water per square meter square. The depth of tank varies from 2.5 to 4 meter. So they are talking, we can see the enclosure tank area is between 50 meter square to 1000 meter square, and the depth of the tank is 2.5 to 4 meters. Next is filter media. What filter media we use? So the filter media what we are using in this particular tank is sand. So the filter media consists of sand layers. It is provided in different layers. Okay, first layer is 90 to 110 centimeter thick. The effective size varies from 0.20 to 0.35. So here you should know something about uniformity coefficient. So this uniformity coefficient is defined as D60 to D10. D10 represents the size of particles in mm such that 10% of the particles are finer than this size. Similarly, the sand particles are finer than D60 size are 60% of total weight. So uniformity coefficient for this particular filter media is from 2 to 3. So the filter media what we are using is sand over here. The thickness of sand layer is 90 to 110 centimeter, and the uniformity coefficient, that is D60 to D10 ratio, is 2 to 3. Then next is base material. Below sand you can see that we have gravel bed. Okay, so this gravel bed is known as base material. The filter media has a base material which is having thickness of 30 to 75 centimeter. Okay, now again this is divided into three parts. One is topmost layer, second one is intermediate layer, and the third one is bottom layer. So that depth is 15 centimeter fixed, but the size of gravel is varying over there. So in the topmost layer we have 3 to 6 thick gravel. Intermediate layer we have 6 to 40 thick gravel, and at the bottom we have 40 to 65 thick gravel layer. So you can see the filter media consists of two parts. One is sand layer and the other one is gravel layer. So you can see the finer is at the top and the coarser is at the bottom. The finer is on top because filtration can occur very easily. If we provide coarse at top, it easily gets clogged up. If we have, for that reason, fine is provided at the top and coarser is at the bottom. Then the next part is under drainage system of this particular slow sand filter. Okay, so now under drainage system you can see the sketch. So when you see it from top, okay, at the bottom of this gravel you have a central drain. Through that central drains we have lateral drains what we have connected. So top when water percolates from top, it first enters into the lateral drains. So this lateral drain spacing you can see, it is varying from 2 to 3 meters. So the spacing is 2 to 3 meters. It is having small porous holes on it, the lateral drains. So when water trickles down, what is happening, it is first entering into the lateral drain and then to the central drain and comes out from the outlet chamber. So this is under drainage system arrangement. On this under drainage system will be having gravel bed. Above gravel bed will be having fine sand. Okay, so this is at the bottom. This is the plan what you are seeing of under drainage system. So now the working of slow sand self filter is simple. Simply put the valve open in the inlet chamber, water flows and moves on the sand, trickles down, all the impurity settles on the sand, all the actions takes place. Which all actions? One is mechanical straining, sedimentation, biological action, electrolytic action, all these takes place and removes the impurities, and we will be having pure water collected at the under drainage system which is taken out from the outlet chamber. So this is the working of slow sand filter. I hope this is clear. The next we have is rapid sand filter. Okay, so the rapid sand filter working also is same as that of slow sand filter, but there is a difference in cleaning process. Okay, so I forgot to tell about cleaning process in case of slow sand filter. So what actually, how the cleaning process is happening in slow sand filter? Cleaning process is accomplished by scraping the top surface, that is we have to completely empty the tank, that is we are not allowing any water to enter into the tank when we are cleaning the tank. So we are going to scrape the top surface of fine sand and remove all the impurities settled to some to particular depth, and again replace the sand to some depth, and then allow the water to pass. That is the cleaning process in case of slow sand filter. Now we'll be seeing rapid sand filter. So here again in rapid sand filter, actually why do we call it as rapid sand filter? Because of the rate of filtration. So rate of filtration in case of rapid sand filter is 3000 to 6000 liter per hour per meter square. So that is the rate of filtration in case of rapid sand filter. So again this rapid sand filter consists of an enclosure tank, filter media, base material and under drainage system. Okay, so enclosure tank, what will be the size of enclosure tank we should see here. Okay, so the enclosure tank is made up of brick masonry or concrete coated with waterproof material. The depth of the tank may vary from 2.5 to 3.5 meter, and the surface area varies from 20 to 50 meters square. They are arranged in series sometimes these tanks. Okay, and it is having a bottom slope. Okay, slope is provided so that water from the lateral drains can easily enter into the main drains. Okay, then next we have is filter media. The filter media used in case of filter is again sand. Okay, the sand is having a uniformity coefficient. So now again uniformity coefficient is coming in picture. It is d60 by d10. So the uniformity coefficient is from 1.2 to 1.7. Okay, remember these numbers. Then next we can make use of anthracite also in case of instead of sand. So we should know what is the filter we are using and what is the uniformity coefficient what we'll be using over there. Then the base material over here is again gravel. So again the base material what we are using here is gravel, and again it is divided into four different layers: topmost layer, two intermediate layers and one bottommost layer, each of 15 centimeter depth. Again the topmost layer is having a grade size of 2 mm to 6 mm. Intermediate layer is having a grade size of 6 to 12 mm, again 12 to 20 mm, and at the bottom we have 20 mm to 50 mm size. So the under drainage system you can see of rapid sand filter, you can see a circular pipe which is having two holes on both the sides of 6 to 12 mm dia. So it is having a particular angle, it is attached at these holes are attached at a particular angle of 30 degrees. Okay, so in this sketch you can see how the lateral drains are attached. So the lateral drains, how they are attached, this is the main drain. The cast iron manifold is nothing but the main drain. Above that we have gravel bed, and above that we will be having sand bed. So this is how it is provided in case of rapid sand filter. So this is the construction part of rapid sand filter. Now how it actually works. So we allow water to flow down, trickle down, pure water we collect. Now how to clean this? Okay, cleaning is very important. The cleaning process in case of rapid sand filter we call it as backwashing. So to backwash we have a wash water pipe, or we have a wash water storage tank on the right hand side you can see of the sketch, and we have a air compressor unit. Okay, so this air compressor unit, you can see it is connected to the gravel, and wash water storage tank is connected to the under drains. So through this under drains, what we are doing, we are allowing the water to spray in upward direction. So when we allow the water to spray in upward direction, what is happening? The impurity settling around the gravel, the impurity settling around the sand will move on top. So the air what is being sent, it is making the particles to be in suspension. So when water is passed in upward direction, what happens? The impurity settling around the sand particles, gravel particles are taken on top, and they are put into that wash water troughs what you see on top, these are called as troughs. So in these troughs we have the washed water collected, which is being sent out. Again, it is being sent out through the inlet chamber, which is connected to a wash water gutter or drain at the bottom. You can see it. So this is backwashing of rapid sand filter and working of rapid sand filter. So next we have is comparison between slow sand filter and rapid sand filter. There are number of points, you can go through it. What is the difference, major difference between slow sand filter and rapid sand filter? So how the base material is provided, which type of base material is provided, what is the filter media you are using, what is the effective size of the base material. So all can be seen over there. How you clean it, whether its efficiency is good or not good. Okay, how much turbidity can be removed, all those differences are put. You can go through the comparison between slow sand filter and rapid sand filter. Then next we have is pressure filter. So now what do you mean by this pressure filter? So you have seen now rapid sand filter, so there water was simply flowing due to gravity, there was no pressure applied on top. Okay, so now here we apply pressure, the arrangement is same. You can see on in the sketch, you have a sand layer, you have a gravel layer, and water is being pushed from top. You have under drainage system at the bottom. Only thing, you have some closed barrels. One is horizontal barrel and the other one is vertical barrel. Means we have two types of pressure filter. One is horizontal pressure filter and the other one is vertical pressure filter. So the pressure filter is a type of rapid sand filter which is in a closed container and through which water passes under pressure. The pressure may vary from 3 to 7 kg per centimeter square and may be developed by pumping. It may be either horizontal type or vertical type. The diameter of vertical varies from 2 to 2.5 meters and length varies from 2.5 to 8 meters. The filter is operated similarly to a gravity type of rapid sand filter, except that the coagulant water is usually applied directly to the filter without mixing, flocculation, or conditioning. So you can see the sketch of rapid sand filter which is applied by pressure. So here the pressure, it is passed under pressure of 3 to 7 kg per centimeter square. Working is same as that of rapid sand filter and cleaning process is also same as that of rapid sand filter. So this is how they actually look. This is vertical type of pressure filter. So they will be having all pressure controlling units to control the pressure. Okay. So next, coming to these filter troubles. So there are many troubles associated with these filters. One is cracking and clogging of filter bed. The other one is formation of mud balls. Next is air binding, sand incrustation, jetting and sand boils, sand leakages. So when we know that filter is having so many troubles, how to avoid these troubles also should be seen. So first you should know what is cracking and clogging of filter beds and why it is occurring. So cracking and clogging of filter bed. Surface clogging and cracking are usually caused by rapid accumulation of solids on top surface of fine media. The compression and shrinkage of soft gelatinous coating on sand grains tend to form cracks in the filter as the head losses increased. These cracks are more prominent near the wall junctions. The effect of such cracks is to permit the dirty matter to penetrate into the filter media, sometimes up to gravel layer. Due to this, the washing of filter and the efficiency of filtration is impaired. This is not a problem in dual or mixed media filters because of greater porosity of their top surface as compared to sand. Uneven clogging of filter follows the formation of mud balls, cracking of bed, and pulling away of sand from the side walls. So this is cracking and clogging of filter beds. The next is formation of mud balls. Mud balls are conglomeration. Conglomeration means mixing of coagulated turbidity, flock, sand, and other binders and are formed near the top of filter media. Mud balls are caused due to insufficient washing of sand grains. So, if cleaning is not proper, this is occurring. Mud may accumulate on sand surface to form a dense mat. During washing, there may be some lateral pressure between the points where the water breaks through and the sticky mud is pushed into lumps or balls of size of a pea, green pea, up to 2 to 5 centimeter and or more in diameter. A 50% expansion of sand in washing is effective in minimizing the production of mud balls. Formation of mud balls can be eliminated by providing an adequate backwash flow rate and a properly designed system for auxiliary score. So this is all about formation of mud balls. Air binding. The condition of air binding is caused by the release of dissolved air and gases from water to form bubbles. These air bubbles occupy the void space of the filter media and the drainage system. Trouble in specifically likely to occur if water is saturated or supersaturated with air in solution. The separation of these dissolved air may be due to the following reasons: the negative head due to excessive loss of head, increase of temperature of water, release of oxygen by algae, avoidance of excessive negative head by providing a water depth of at least 1.5 meter. So this can also be controlled by avoiding supersaturation of water in air, control of algae growth, and avoidance of warming up of water as it passes through the plant. This is all about air binding. The next we have is sand incrustation. Sand incrustation may occur either due to deposition of sticky gelatinous materials from the influent water or due to an after crystallization of calcium carbonate in case where heavy lime treatment of water is practiced. Due to this, the sand grains enlarge and effective size of sand is changed. This can be minimized by carbonating the influent, thereby dissolving both calcium carbonate and any manganese that might have deposited on sand grain. Sodium hexametaphosphate may also be used in small plants to keep calcium carbonate in dissolved state. The next we have is jetting and sand boils. Jetting and sand boils results during backwashing. When backwash water flows follows path of at least resistance and break through to the scattered points due to small difference in porosity and permeability of sand and gravels. So this jetting action can be minimized by providing or it can be eliminated by providing 8 centimeter layer of coarse garnet or illuminate between the fine media and gravel. Next is sand leakage. Sand leakage or downward migration and escape of fine results when layers of smallest gravel are displaced during backwashing. It can be minimized by properly proportioning the sand and gravel layers, and also by using coarse garnet layer between the fine media and gravel media. So these are filter troubles. So these filter troubles are very important. You should know how they occur and what are the methods or preventions taken to avoid these filter troubles. So with this we complete part of filtration. Thank you.